Hey, it's Dr. Pat again. We're looking at the second part of our introduction to functions. Just want to talk about the four different ways that we can represent this function relationship, how two things are related. So we can do it with the table of data. In real life, you see that a lot. That's one of our really popular ways of representing functions is with table of data. We can do pictures and graphs. That's another very popular way of doing it. But if you really want to crunch out some things, you really want to get an understanding of what's going on, that's where the equation will come into play. Or you can actually just write it in words to give a paragraph. Okay, so let's take a look at some more things going on here. So interpretation of functions, remember that the definition was talking about starting with one thing and then we're ending up, we're directly connected to one other thing. Okay, so the thing that we start with, the thing we know, is called the independent variable. And the second thing, the output, that's the thing we want to know. That's what we're trying to calculate. That's what we're trying to predict. That's the dependent variable. Because what we get always depends on what we start with. Okay, so that's a kind of our basic relationship. If you're looking at our notation, you're looking at f of x. That's another way for, it just stands for y. It's a formal notation. Talk about that in a moment. You've got data points. You've got x comma y, input, output. So that's just the way we put it together. So we list our input, what we're starting with first, and then our second thing, our result, is what we put second. You might also see a little bit more formally. You'll see this x and then comma f of x. Just remember, f of x is the same thing as y. So you might see this may look a little awkward for you, but it's basically meaning the same thing. We got an x and y, input, output. And then our next one we're looking at graphically. Most likely x is our horizontal, y is our vertical. Our input is on the horizontal, our output's on the vertical. It's not always like that. There are some relationships in some fields where they'll actually do it a little bit opposite. They have a particular reason. So I just want to say that, you know, for us math people, we like to be consistent. So this is what we like to do. But in real life, you may see this a little bit different. Okay, so now let's get into our function notation. Let's start looking at this thing right over here on the left-hand side. That's a label. This whole package deal is just a naming device. And us math people, I like to say lazy. We're efficient because instead of writing the whole name out, we just give it a letter. So like this could be Fred. Okay, so my formula for Fred. And so that's what the F is relating. And then we've got this package deal with the parentheses x. Well, that x right there is our input. The things that you see inside the parentheses, that's what we're going to plug into the formula. Okay, so that's our input. And then, of course, on the side over here is the actual formula itself. So we've got a labeling system over here, also letting us know who the input is. And then we have the formula on the right-hand side. So let's take a look at this. This is labeled as f of x. So that's the word of it. Just think of it as a foxy kind of thing to say. Yeah, I just did that. I'm doing that for you just to keep things, I would say fresh, but I'm not. I'm an old guy. Okay, so let's get into it. So this is our formula that we want to play. So now notice that I put a 2 in there. There's a 2 inside the parentheses. That's telling me my input is 2. So wherever I see an x in this original formula, notice I put the 2 there. So, and then we can just crunch it out, calculate, and get our 11. So whatever you see inside of this parentheses is what we plug in there. Okay, and so if I've got a letter here, I've got U. Now remember, this is f of u, not fu. This is f of u. And so since I've got a u inside this parentheses, that's what I'll replace the x with. And all that does is just replace the letters. I can't really do much with it. It's just a change of variable in a way. Now you can also put a combination of letters and numbers. So I've got an f of u plus 2. So where I see this x right here, going to put a u plus 2. And so that's where we're going to then calculate that out. We can multiply, distribute this 3 through. That's going to make a 6. Add that 6 to a 5, and that's where you're seeing that 11. So just doing a little distribution there. Okay, so whatever you see inside the parentheses is what is our input. That's what we're putting into the formula. Okay, so you can put in numbers, you can put in letters, combinations. You could even put in your favorite band and put that in as well. All right, so another example would be tables, the numerical perspective. So just looking at a table of data for Pie Daddy pizzas, and starting from time 0 is 2005. So each of these numbers right here is the number of years since 2005. And so if we're looking for what does S parentheses 4 stand for? Okay, now that's the math notation. Okay, so math notation is very efficient. It just puts it down in nice, easy, or, the shortest way you can say something. And so what we're looking at here is technically S parentheses 4 represents the sales for Pie Daddy Pizza for the year 2009. Because remember, F, that's 4, this 4 here is the number of years after 2004. Okay, and so that's what it would stand for. Now, what's the value of S parentheses 4? Well, the sales for Pie Daddy Pizza in 2009, let's see right here, would be $17 million. Hey, nice job. And so that's kind of what, just remember these units here. So this T value really represents the number of years after 2005. And then these numbers here, the answer's not 17. So if somebody would have given me the answer of 17, I'd have to mark that wrong on a test, because that 17 has a meaning. It has a meaning of $17 million. Okay, so that's the kind of just an introduction of our functions, our function notation. And so I've got one more example, and we'll look at piecewise functions. So thanks for watching. Hopefully I'll catch you later.